So the theme today is going to be Christmas because my daughter, Lexi, the one that's in Finland, is actually, as we speak, in Santa Claus Village in Rovaniemi on the Arctic Circle. The picture on the left, this right here, are all the letters from Santa across the world. This is her team, and obviously she's one of the only brunettes. And this is just a picture of Santa's village in the nighttime during the middle of the winter when it snows. So now we'll get on to math. We're going to be talking about variation functions and mathematical models. Okay, there are three different ways to write an equation with variation. The first is y, oops, didn't want that. Y equals kx, where k is called the constant of variation. An example would be b varies directly with the square of m. So b varies directly with the square of m. Varies inversely. So varies inversely would be y equals the constant over x. An example of that would be b varies inversely with the square root of m. So b varies inversely with the square root of m. And varies jointly. So just think about joints sticking together. Jointly is just multiples multiplied together. So varies jointly would be y equals k, then this would be x, z, whatever. So an example of that would be b varies jointly. So b varies jointly with twice m, the square of j, and let's change that to z and z. So, variations worksheet number 1, let's see how this works. The number of pounds you weigh is directly proportional to the number of kilograms you are. So the pounds you weigh is directly proportional to the kilograms. I like to use letters instead of x and y because it just helps me remember which is which as I'm working through the equation or working through the problem. Kay Dent steps on a scale calibrated in kilograms and finds that she is 50 kilograms. She knows she weighs 110 pounds. A, write an equation expressing pounds in terms of kilograms. So I know that she has a relationship. I don't know what K is, but I know we know the relationship between pounds and kilograms. So if I were to solve this for K, I would divide by 50 and get 2.2 would be the constant of variation. So now I'm not done. I need to put it back into this equation. So I'm going to take K and put it back into the original. So P equals K times G. B says, how many pounds would a person be if the scale read 100 kilograms? So how many pounds would I be if the scale read 100 kilograms? And actually, I know the constant of variation is 2.2, so I know these pounds would equal 220 pounds. Excuse the dogs in the background. Okay, so what if the scale read 25? So 2.2, I'm going to plug in the kilograms, and I get 55 pounds. C. So, what does 2.2 stand for in the real world? Well, if I were to solve that original equation, so this equation, and just get the constant by itself, I would get P over G equals 2.2 over 1. So what it stands for is 2.2 pounds per kilogram. Okay. Let's move on to mathematical models. So let's look at this mathematical model. All model means is an equation, a situation, a problem. So you're driving home from a friend's house on the other side of the town. When you are 11 kilometers away from home, you've driven 10 minutes, etc., etc. First A, we want to write an equation that models this situation. Okay, so it tells me right in the middle that I assume this is linear. Okay, and I know for linear I need a slope and a point, at least. I need a y-intercept or something like that to be able to write the equation. Okay, well, I look at this and I don't see a slope. I don't see a y-intercept. I see a couple of numbers that could be points. But remember, before I can put these in ordered pairs of x and y, I have to know what x stands for and what y stands for. So I have to define my variables, and it's really important in a mathematical model that you talk about the dependent variable and the independent variable. X is always the independent variable, y is always the dependent variable. And if I look, I can see that I have 8 kilometers away when I've driven 15 minutes, okay? 11 kilometers away from home when I've driven 10 minutes. So what depends on what? Do the kilometers depend on my minutes, or do my minutes depend on the kilometers? Well, the amount I drive depends on how long I've been driving. So the kilometers, I'm going to say kilometers towards home, depend on the minutes I'm driving. Now I can create my ordered pairs out of that information. So I have, let's see, 10 minutes and 11 kilometers and 15 minutes and 8 kilometers. From here, I'm going to find the slope. So I'm going to pause. You should be able to find the slope. The slope should be -3/5. And I'm now going to pause and put this into point slope form. It doesn't matter which point I use. I can either use the 10/11 or I can use 15/8. I obviously use 10/11. And if I solve this for y, I'm going to get y equals -3/5x plus 6. And then if I add 11, I'm going to get plus 17. So to graph this, I'm just going to plot the y-intercept, which is 17. Don't forget, this is what I plot first, the 17. Now I'm going to do the slope, which is rise over run. I have a -3 rise, so I'm going to go down 3/5, down 3/5, down 3/5, and that will be my graph. Answer question C. How much further do I have to go if I've been driving for 25 minutes? Okay, remember x stands for minutes. So y is the kilometers, -3/5. I'm going to plug in the 25 minutes plus 17. This is going to equal -15 plus 17. So I have 2 kilometers left to go. D asks what the slope and the y-intercept stand for. Well, the y-intercept, which is the ordered pair 0, 17, stands for at 0 minutes, I'm 17 kilometers. Well, let's be a little bit more specific. Okay, I am 17 kilometers from home. The slope, which is -3/5, means for every y over the x. Don't forget this is delta y over delta x. For every 3 kilometers takes 5 minutes. 3 kilometers takes 5 minutes. E, when do I get home? Well, I get home when I'm at 0 kilometers, so I'm going to do it backwards this time. 0 kilometers equals negative 3.5 times some amount of time plus 17. I'm going to subtract 17. I'm going to multiply by the reciprocal. So I will get home in 10.2 minutes. The last question, F, asks for what a real-world domain and range would be. So I obviously have minutes, but I can't go negative in minutes, right? And I'm going to get home at somewhere around here. So my real-world domain is going to be from 0 minutes to 10.2 because that's when I get home. My real-world range, well, I go from 0 to 17 kilometers from home. So that would be my real-world domain and range. You guys have a great night.